In today's tutorial we will have a look at phase transfer catalysis. Imagine we have a reaction flask with two liquid phases, one unpolar organic solvent here on top containing the substrate we want to make an organic reaction with, and then here we have an aqueous phase containing salts as reagents, for instance sodium hydroxide as a base or potassium permanganate as an oxidizing agent. So since those salts are practically insoluble in the unpolar organic solvent, we need something that helps the transfer of those reactive salts into the organic phase. Well, if we would simply choose a polar organic solvent, then we won't have those two phases. Yeah? But however, if such a hydroxide could be delivered into an unpolar organic phase, then it has an even higher reactivity, because it is somewhat, or you could say, naked within that organic layer. It is not stabilized by water molecules, by hydrogen bridging bonds, and so on. Yeah? So, but for the transfer we need a catalyst. And the catalyst could be, for instance, such an ammonium salt. This ammonium salt is soluble in the water layer as well in the organic layer, and in the water layer an exchange will take place in equilibrium. The chloride is then exchanged to OH minus, hydroxyl and ion, and then also in equilibrium this ammonium group will carry the hydroxide and ion into the organic phase, and there it could react with its even higher reactivity. But what is important in such a case is that we have a phase boundary as large as possible, and that we can induce by vigorous stirring. Another example, especially interesting example for phase transfer catalysts, are crown ethers. Here we have a structure of 18 crown 6. This is this molecule, and in that case a potassium cation would excellently fit into this ring of those oxygens, all coordinating, and of course the counter anion will stay in close proximity. For instance, the manganate and ion, permanganate and ion here, and then this molecule, this complex, would go into the organic phase. Well, generally we would prefer to use an ammonium salt like that, because it's just much cheaper compared to a crown ether. But imagine we need to avoid water at all, because our substrate is sensitive to hydrolysis. Then we would skip the water. We would just put in potassium permanganate or potassium hydroxide as a powder, and also in this case we have two phases. We have a solid phase and a liquid organic phase. And a crown ether like this would also ideally work in that case, catalyzing the transfer from the solid phase to the organic phase. Thanks for listening.